road. So now, we did example 19. Adding and subtracting fractions is identical in process. Both fractions already have a common denominator. We just have to subtract the numerators, add or subtract the numerators, and keep the denominator. So example 20, they go easy on us. 7 over 8 plus 3 over 8. Now when you're adding or subtracting fractions, 7 over 8 plus 3 over 8 equals. Now since the denominators, let's go back to the pi example. 1, 2. This is a pi, 1 pi divided into 8. So that really represents, if all the pi were here, it's 8 over 8. So what they're saying is that 7/8 plus 3/8, so we're going to put the 8 here, and we're going to add these two, and we get 10 over 8. So we haven't reduced it. We can divide both things by 2. Let's do that now. 5 over 4. So let's look at this pi. So we have 2 pi's here. 2 parts of pi's. Let's illustrate with an example. 1, 2, 3, 4, 5. Okay. So pi number 1 is basically all this is the pi. This is empty. Somebody ate it. And 3 over 8 is really so this is 7 pieces of pi, and this is 3 pieces of pi. So if we were to add those pieces of pi together, we would get one complete pi, right? Here plus one of these. Right? And then we'd have another pi. These two, and the rest would be empty. So we'd effectively have 10 over 8. So 7/8 plus 3/8 gives us 10/8. Now, because mathematicians are fussy, they always want us to reduce, right? They always want us to reduce the fraction. So I divided everything by 2, 5 over 4. What this really means is that if you were to divide everything into 2, let's erase that. All right. There you go. A pi would now be worth 4. And you would have 5 pieces of pi. 1, 2, 3, 4, 5. It's just another way of saying the same thing, all right, using less numbers. I think that's a pretty awesome example I just gave you there. All right. Let's clear this, MF. Moving along. While 5 over 4 can be written as a mixed number, in algebra, 1 over 4, in algebra we almost never use mixed numbers. For this reason, we can always use the improper fraction, not the mixed number. So I guess what they're saying, an improper fraction is anything worth more than 1. So instead of saying, well, you saw before there was 1 pi and 1/4 of a pi, that's basically what they're saying here. Example 21, this is a subtraction. Same thing, all right, 13 over 6 minus 9 over 6. Now they made it easy because the denominator is the same. So I'm just going to grab my Hardy pen. All right, so we have 13 over 6, I'm not sure that's the right pen, minus 9 over 6 equals. So we have common denominator. So we can right away subtract the two top numbers. 13 minus 9 equals 4 over 6. Now, mathematicians are sticklers on this. They really want you to reduce this. So if you have 2 even numbers right away, 2 over 3, is that our answer? Yes, it is. If the denominators do not match, we first have to identify the lowest common denominator and build up the fraction by multiplying numerators and denominators by the same number so the denominator is built up to the lowest common denominator, which is a very complicated way of saying we have to multiply the numerator and denominator so that both denominators are the same. So I'm going to clear this guy. Example 22. 5 over 6 plus 4 over 9. Lowest common denominator. They're telling you the answer, but I mean, that's really... Okay, hold on. 5 over 6 plus 4 over 9. So the trick is, if I took 9 times 2, 9 times 3, 9 times 4 equals 18, equals 27, equals 36. Now if I did 6 times 2, 3, 4, 5, 6. So 6 times 2 equals 12. 6 times 3 equals 18. 6 times 4 equals 24. 6 times 5 equals 30. 6 times 6 equals 36. So when we're looking for the lowest common denominator, we have one here. We have one here. Right? If I multiply this guy by 4, I'll get 36. If I multiply this guy by 6, I'll also get 36 for the denominator. But we don't want to work with big numbers. They're asking for the lowest common denominator. So it would be these two guys, right? The ones that give 18. So let's write this a little bit more sexy. 5 over 6 plus 4 over 9. So we're going to multiply this side, we said, by 3. Right? The 6 we're going to multiply by 3. And this side we're going to multiply by 2. So we're going to do this and this, this and this, this and this, this and this. So let's do this. 3 times 5, 15. 3 times 6, 18. 2 times 4, 8. 2 times 9, 18. Whoa, now we're in business. Check this out. Same denominator. So we can just add, right? 15 plus 8 equals 23 over 18. That looks pretty good. I think that's our solution. Yes, it is. So moving along, let's clear this mess. Example 23. 2 over 3 minus 1 over 6. That's a pretty sexy problem. Let's look at why. All right, number 23. 2 over 3 minus 1 over 6 equals. Now they're saying that the lowest common denominator is 6. So what they're saying here is that sometimes you don't have to multiply both fractions to get a lowest common denominator. Sometimes only one needs to be raised and you're in business. So 2 times 3 equals 6. Boom! We got it. So if we multiply times 2 both sides, we're going to be okay. So let's do this. So we have minus 1 over 6 here, this guy. Now 2 over 3. 2 times 2 equals 4. 2 times 3 equals 6. Boom, we got it. We're in business. See what I did there? Only this guy was modified. So equals, put the 6 here, 4 minus 1 equals 3. Can you divide these guys? Yes, you can. 3 over 6 is really 1 over 2. And that's our solution. And now we're going to practice. So watch the next video for the practice.